Alright, welcome back, ladies and gents. Today we're going to be using Venn diagrams to show relationships for events. So there's something called mutually exclusive. Now when things are mutually exclusive, that means their events do not overlap. So if I look at the event of getting a heads and the event of getting a tails, there's no overlap between them. I'm either going to get heads or tails. I can never have both. So there's no middle. So you guys have seen a Venn diagram before, right? Probably in English class. You know, something that might have an overlap would be people who own a cat and people who own a dog, right? There are some people who own both. Okay? But heads or tails would not have any overlap. So let's look at a specific example. When rolling a die, the outcome is 1 through 6. We've talked about this many times now. None of these can occur at the same time, right? But if we look at a specific event, such as event E, the event of rolling an even number, and the event F, the event of rolling a number greater than 3. So a number greater than 3 would be 4, 5, and 6, right? An even number would be 2, 4, and 6, right? So I can see that 4 and 6 are in both of mine, so that's going to go in the middle part. That means they're in event E and F. But 2 is only in event E, and 5 is only in event F, okay? Now, usually you'd want all of your numbers represented in your outcome, so we usually put this box around the circles, okay? And 1 and 3 are not used, right? So 1 and 3 just kind of go on the outside of this box, okay? So I have 1, 2, 3, 4, 5, 6. I have all my numbers. These numbers are specifically in event E or F or in both. Okay, so we're going to do another one. So put this data in a Venn diagram. There are 10 cards, each printed with the numbers 16 to 25. Okay, and we have event A is getting an 18, a 21, or a 24, and event B is getting a 20 and 25. So if I look at this, there's no overlap between A and B, right? So A and B would be two separate circles. I'll label this one A and this one B. So A is going to have the numbers 18, 21, and 24. Event B is going to have 20 and 25. And the numbers left over are 16, 17, 18's used, 19's not used, 20, 21, 22, 23, 24, 25. So I want to make sure I include my entire sample space. So if it's not used in any of the events, it just kind of goes off to the side. Like here I put it off to this side, you could put them at the bottom, you could put them all around these if you really wanted to. But that's what this square rectangle is for, okay? So my question here is, what is the probability of event A? So the probability of event A. Remember, there's 3 options, so my top number is 3, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total options, okay? Probability of event B would be 2 options out of 10, which reduces to 1/5. Okay? So the Venn diagram just helps you to kind of organize the information. Okay, oops, let's keep it going here. So I have one more for you. A name is randomly chosen from a list of names: Bill, Jesse, Eva, Chloe, Mary, Ruth, Kim, Henry, Elsa, and Sean. Let X be the event of choosing the name with 2 vowels. So in X, sometimes it's helpful to write it off to the side, is a name with 2 vowels. So Jesse, Eva, Chloe has 2 vowels, Chloe. Maybe you just circle them if you really don't want to have to rewrite everything. Henry, Elsa, and Sean. And Y, oops, I'm sorry, you guys are really cockeyed here. Y is going to be the event of choosing a name made up of 3 letters, okay? So the names that have 3 letters, I'll write this in pink, okay? 3 letters would be Eva, Kim, and that's it, right? So if I call this one X and this one Y, okay, the things that overlap are the ones that are purple and pink. So Eva is the only gal who's in the middle here. Everybody in purple is in my X category here. So Jesse, Chloe, Eva's already in. Mary's not in, Elsa, and Sean. And then Kim is my only one in Y. Now all these other names that I didn't circle are right in pink. So Bill, Mary, Ruth go on the outside here. Henry. Okay? So are X and Y mutually exclusive? They are not, because they have Eva as an overlap. Okay. Now the probability of X, remember I have 1, 2, 3, 4 names here out of 4, 5, 6, 7, 8, 9, 10 things here. And if I reduce this, if I divide top and bottom by 2, that's going to give me 2/5. The probability of finding y is going to be 1 out of 10, right? And that's already reduced. Okay, go ahead and work on this exit slip, and you will be ready and raring to go there. Okay, have a wonderful day. We'll talk to you tomorrow. Bye.